Welcome on IrriWatch. In this video, water-related data components will be explained on pixel and field level. We will explain in this video on pixel level, Irrigation Advice Map, soil moisture root zone, actual evapotranspiration, and actual evapotranspiration due to applied water. And at field level, fullness root zone water tank, minimum advised water, maximum advised water, time until next irrigation, area percentage over wetted, area percentage requiring irrigation, field uniformity soil moisture, applied water and field irrigation efficiency. We start off with number 1, Irrigation Advice Map. To optimize production and water use, you need to know when to irrigate, and important when not to. We use a traffic light system to advise you if you need to irrigate today. Orange means your field needs irrigation. Red means your field needs urgent irrigation. Green means your field does not need irrigation. Blue means your field is over-irrigated, and brown means your field does not have vegetation. We only give irrigation advice when the vegetation cover is higher than 10%. Every pixel has its own irrigation advice, so you can see inside a field which parts need to be irrigated and which not. If your field shows green pixels, it means it does not need irrigation today. However, for the next day it may change to an orange color. Number 2, soil moisture root zone. The irrigation advice is based on soil moisture. This is the volumetric soil water content expressed in cubic centimeter of water per cubic centimeter of soil. Soil moisture tells you the absolute amount of water in the soil, like how wet or dry your field is. If you click on a field in IrriWatch, the timeline graph pops up. The first one is the virtual soil moisture probe. The dark blue line is the average soil moisture of the field over the whole period, since you started your registration on the IrriWatch portal. If the soil moisture is in the blue zone, above field capacity, the Irrigation Advice Map shows over-irrigation. If the soil moisture is in the red zone, below critical soil moisture, the moment the crop stress emerged, the irrigation map shows irrigation or urgent irrigation. The critical soil moisture line is changing because weather conditions have influence on the onset of the crop water stress level. If the weather is hot, the critical soil moisture will rise, and water stress occurs sooner than for cold weather. If the soil moisture root zone is in the green zone, it is above critical point and below field capacity. Your field should be in the green zone for optimal production and water use for your crop. We do not measure soil moisture directly, but we calculate soil moisture via the leaf temperature. Just like a human body, temperature tells you what happens inside. Because we use temperature to show the soil moisture of the whole root zone, we do not measure soil moisture on a certain root depth like a soil moisture probe does. Crops and soils react differently to weather conditions and irrigation water supply. It is important for our calculations to have the right crop, soil, and irrigation type information of your fields. For example, some crops respond immediately to soil moisture, like tomato, while other crops do not care, like barley. Another way to explain how wet or dry your field is the fullness of the root zone. Number 3, fullness root zone water tank. Imagine the root zone is a water tank. How much of the tank is filled with water? The fullness root zone water tank shows the percentage of water in the tank. At 100%, the root zone is completely full at field capacity, which means the root zone cannot take any more water. If you irrigate more, the soil starts spilling like a tank that is overflowing. For your field, you want 40 to 60% of your tank filled with water, depending on the drought sensitivity of the crop. If the fullness is low, we advise you to irrigate to fill the water tank of your root zone. If IrriWatch advises you to irrigate, we also advise you how much water you should irrigate with. Number 4 and 5, minimum and maximum advised water. We advise you with a minimum and maximum millimeters for every field. The minimum application is based on recovering actual evapotranspiration or to bring back the moisture to critical level. The maximum application is related to refilling the water tank to 100% fullness. Since you are the irrigator and you know how your fields work, you decide on the exact amount of water to supply. If IrriWatch advises you not to irrigate, we give an estimation how many days you should wait. Number 6. Time until next irrigation. The days until next irrigation will be 0 for dry fields because we advise to irrigate today. But for wetter fields, the number of days is higher. This parameter is updating every day, so the number of days may change because of other weather conditions. Remember that we determine for every pixel whether it should be irrigated or not. So every 10 meter by 10 meter is checked on whether it needs water. If you want to know what percentage of your field is too dry or too wet, you can go to number 7 and number 8. Area percentage over wetted and area percentage requiring irrigation. This shows per field which percentage is overwetted or which percentage requires irrigation because it is too dry already. A high percentage of area overwetted means the soil moisture is above field capacity, and a high percentage of area requiring irrigation means the soil moisture is lower than the critical soil moisture. Let's go back to the virtual soil moisture probe. As you can see, there is a shaded area in the graph. This is the maximum and minimum soil moisture of your field. This says a lot about the uniformity. It is non-uniform if the dry and wet soils both occur. By absence of rainfall, this is often related to the distribution of irrigation water in your field. If the shaded area is large, the field is not uniform. But if the shaded area is narrow, your field is very homogeneously managed. Number 9. Soil moisture field uniformity. If the irrigation advice or soil moisture root zone pixel map shows high variability, then you can conclude that irrigation water is not equally distributed or there is a large variability of soil properties. It is important to keep your field uniform. Field uniformity is expressed as the standard deviation divided by the mean soil moisture. A field with 0.00 uniformity means that it is 100% uniform. We are moving on to number 10, actual evapotranspiration. IrriWatch measures the actual evapotranspiration of the crop in millimeters per day. It is an indirect measurement through the surface energy balance. We compute how much energy is consumed by evapotranspiration. This method is much more accurate than applying the well-known Penman-Monteith equation and a crop coefficient, Kc. This method is from the 60s and is an old method. The ET originates from both applied water and precipitation. This is how we obtain precipitation data. Number 11, precipitation. IrriWatch is based on spatial data, and so is precipitation. We have very detailed information about soil moisture and ET, but rainfall is having a coarser grid. So if you have more detailed rainfall data, like at a local weather automated station, there are IT producers in place to take your local rain gauge measurements. If rainfall is not the source of water, then it has to be applied water. Number 12, applied water. The applied water is shown in millimeters per field average over the last 10 days. This value shows you how much the irrigator has irrigated on average. It is valuable data to keep on track for the farmer. The value is smeared across 10 days because this parameter is on daily level, not accurate enough. We can also tell you how much water is evaporated from your irrigations. Number 13. Actual evapotranspiration due to applied water. ET due to applied water is the amount of irrigation water that is transported into the atmosphere and is blown away. It is an example of water that is consumed due to the irrigation process only. On pixel level, we show you the actual evapotranspiration from applied water since the start of the data subscription. For irrigated fields with little rainfall, ET and ET applied water are rather similar. For irrigation systems with more rainfall, ET and ET applied water can be substantially different. As a farmer, you want to irrigate as efficient as possible. Nobody wants to waste water and energy. Number 14. Field irrigation efficiency. The field irrigation efficiency shows the percentage of your applied water being used by the crop. If 80% of your irrigation water is used by the plant, the field irrigation efficiency is 80%. The farmers can keep track of the efficiencies per field and can make a decision to change irrigation methods for fields with low efficiencies. Thanks for listening. By the way, the IrriWatch portal is also explaining all the data parameters if you click on the red question mark symbol. There are also more explanatory videos in the description below, like the production parameters explanation. We are happy to assist you.